Okay, today is 15.3, constructing exponential functions. Okay, this is something I don't remember actually learning, but I guess I'm sure I did at some point in time. So the first thing we're doing is we're representing discrete exponential functions. Okay, an exponential function is a function whose successive output values are related by a constant ratio. An exponential function can be represented by an equation in the form of f of x equals a times b to the power of x, where a, b, and x are real numbers, and a cannot be 0, b is greater than 0, and b cannot be 1. The constant ratio is the base b. Okay, so why don't we go ahead and outline all that? Go ahead and write all that. I think that's some good information for us to write. Okay, when evaluating exponential functions, you will need to use the property of exponents, including 0 and negative exponents. Recall that for any non-zero number c to the power of 0 is equal to 1 when c does not equal 0, and c to the negative n is equal to 1 over c to the power of n, where c again cannot be equal to 0. Again, I want you to just write that just to have it in an instant recall for you, okay? Good. All right. So, complete the table for each function using the given domain, then graph the function using the ordered pairs from the table. So a here is f of x equals 3 times 1/2 to the power of x, with a domain of -1, 0, 1, 2, 3, and 4. Now look, they've already done the first one for us, okay? And as you can see that is equal to 6. So the point here is -1, comma 6, because that's where our x is, right? Remember that. We're putting in our domain is being put into where the x is, which is here. So please remember that. Remember, you are writing these examples. Now, what I'm going to do is I'm going to go ahead and pause the video. I'm going to work out all these numbers, and then we'll come back and I'll go over them with you. All right, after a bunch of number crunching here, remember that our x is going in as the power. Now, I didn't show that here at all, but you need to remember that. All right, so that here, this one right here, and I'm just going to write this one here, f of 0 is equal to 3 times 1/2 to the power of 0, and that equals, I'll go ahead and finish this one for you. Why not? Just so that you have at least one example that you can look back on. Remember, you really should just be making this a calculator exercise. Anything to the power of 0 is 1, so that equals 3. Okay, I didn't work any of these others out. Now I'm going to go ahead and pause the video and graph this so you can see what it looks like. All right, because you don't think you need me to graph it for you. Okay, I went ahead and plotted those points, and I'm going to go ahead and draw my line, and it should come out to be a curve. And you can even tell from the points that I plotted that this is going to be a curve. Okay, exponential growth is a curve. Okay, so they should all have some type of curvature to it. Okay, so that's that first one there. Now let's go on to the next one. Okay, I'm going to do the same thing here I did in the last one. So this is f of x is equal to 3 times 4/3 to the power of x, and 4/3 is being put to the power of x. So when you're putting in your domain numbers, you're putting them in for x. So they've worked out they've started to work this one out. I'm going to go ahead and finish it, but this is the only one I'm going to do like this. So this is the same thing as this, right? Anything over 1, you just flip it. So that's this. All right, this 3 squared is 9, 4 squared is 16. Okay, am I doing that wrong? I don't think I'm doing that wrong. But then you multiply 9 times 3 and you get 27/16. And then that is 1 and 11/16. Because when I subtract 16 from 27, I should get, so 27 minus 16 equals 11. Excellent. I can do basic math in my head. It's awesome. All right, so I'm going to do the rest of these out. And again, I might show you one more how to do this, and that'll be it. Okay, so I'm going to pause the video, and I'm going to go ahead and... Okay, so I waited to the very last one to do. All right, so we got 3 times 4/3 to the power of 2, which is equal to 3 times 16 ninths. Okay, you take 16 and you multiply that. Well, now look, you can make this easier. Look, this simplifies, right? So this is just 3, so that's 16/3. All right, but 16/3 is the same thing as 5 1/3. So that works out to 5 1/3, and that's what I'm just doing here. Okay, now I'm going to pause the video again to graph it so you can see the graph. Okay, so I went ahead and plotted the points. I drew the line. Now look, I'll go ahead and move the line off so you can see where my points are plotted. And as you can see, they make a curve. And again, anything that is being put to the power as exponential in ideas is going to have a curve to it when you graph it, all right? So I just wanted to let you know that. All right, next. So now, this is your turn, so I want you to pause the video and go ahead and do this. Remember, you have a graph on the other side of your whiteboard, so remember to utilize that graph. As a matter of fact, you should just do all of this on the graphing side. Let me see if there's a 5. I don't think there's a 5. Excellent, there's not. Let me go past. Okay, excellent. All right, constructing exponential functions from verbal descriptions. So this is the hard part, right? This is where you got word ideas, okay? So you can write an equation for an exponential function f of x equals a times b to the power of x by finding or calculating the value of a and b. The value of a is the value of a function when x equals 0. The value of b is the common ratio of successive functions' values. So you would take b is equal to f of x plus 1 divided by f of x. It's kind of like what we did when we were finding ratios, okay? For discrete functions with integers or whole number domains, these will be successive values of the function. Okay, so we're going to go ahead and write an equation for the function, all right? When a piece of paper is folded in half, the total thickness doubles. Suppose an unfolded piece of paper is 1/10 of a millimeter thick. The total thickness T of n of a paper is an exponential value, is an exponential function of the number of folds n. All right. Okay, that was my fault. I should have understood this a little bit better. All right, so it says when a piece of paper is folded in half, the total thickness doubles. All right. Now we have a starting point of A. It says suppose an unfolded piece of paper is 1/10 of a millimeter thick. So that's our A. So A is equal to 1/10 of a millimeter. Okay. Now our B is going to be doubles. The total thickness doubles. So our B is going to be 2, and X or N is going to be the number of folds. So our total thickness will be T of N, because that's what they want us to use, the total thickness. The total thickness is this, right? So you're going to have, there's our A, and here's our B. We're going to put it in parentheses because that is not 12 100ths. I mean, yes, 12 100ths. That is 1/10 times 2 to the power of n. Make sure you use parentheses there. It's very important to separate those numbers. Okay, don't mess that up. All right, so that came out kind of easy, right? Let's see if we can do another one. Okay, I'm going to extend this to make sure that we can see this, okay? Sorry. All right. A savings account with an initial balance of $1,000. So we have an initial idea. Earns 1% interest per month. That means that the balance grows by a factor of 1 and 1/100th each month if no deposits or withdrawals are made. The account balance in dollars B of t is the exponential function of the time t in months after the initial deposit. So what our B is our B is now we got to be careful here, because if I just put 1% here, that's going to bring my balance down to 1% of this $1,000. So we can't have that. So really what it is we have to include that $1,000, so we do it like this. Okay? So that's what it needs to look like. All right? And then so our total, or our function, our balance after X number of time in months is going to equal 1,000 times 1 and 100ths t. They want us to use t. Okay, so t is the number of months. Okay, where t equals number of months. Okay, if you can get that, take that. That's actually a pretty good deal. I haven't seen anything that good ever. All right, so here I think this next one is you're going to be trying this one on your own. Ta-da! Oh boy, what is this? Hey, I didn't even put one up there for you. So let me go back and do that. Come on. There we go. Sorry about that. Okay, here's your turn. All right, make sure you pause the video and try this. All right, all of a sudden I have another your turn. Did I mess up here? What did I do wrong here? I think something got messed up here. All right, let me redo that. Sorry about that. Minor technical difficulties. All right, so here we go. Example 3. It says, write an equation for the function that includes the points. So now what we're doing is we're using points to write functions. And all of a sudden I feel like this... Sorry about that. Something happened. I don't know what. Okay, so constructing exponential functions from input-output pairs. Okay, so here we go. So it says write an equation for the function that includes the points 3, 12, and 4, 24. The first thing that we need to do is we need to find our b. You work kind of backwards here, okay? And I'll show you why. Okay, we got to take, so remember to find b, we take f of x plus 1 and divide it by f of x. So we need consecutive terms. And they've given us consecutive terms. They give us the third term and the fourth term. So we take 24, we divide it by 12, and that gives us 2. So we know that b is equal to 2. Now we need to find our a. Well, to do that, we know, this is what we know. We know that a times 2 to the power of 3 equals 24. Equals 12. Okay? And the reason why we know that is because, remember, this is our power and this is the output. And as long as we know those two things, we should be able to set this up. So from here, we can go like this. We know that a and 2 to the power of 3 is 8 equals 12. Now to figure out a, we just divide by 8. And we get a is equal to 12/8. But that's not how we write it, right? They're both divisible by 4, right? So that's 3/2. So our a is equal to 3/2. So our function, our f of x, is equal to our a, which is 3/2, times 2. Again, I'm using, since I had the multiplication dot there, I didn't need to use that parentheses there. Okay, 2 to the power of x. So remember to do that, all right? So here we go. Let's try b. All right, so the first thing I do is I got to find my b. My b is my f of x plus 1 divided by my f of x, which means we need 2 consecutive terms. So we're going to take 9/4 and divide it by 3. Okay, and then that's the same as this. 9/4 divided by 3, which is the same thing as 9/4 times 1/3. Okay, do some cross simplifying, and we find out that this is 3/4. So we know our b. Our b is equal to 3/4. Now, we know that when we put in x equals 1, we get 3. So our a times 3/4 to the power of 1 equals 3. All we need to do is just reverse engineer this. So we do this. We multiply by 4/3 on each side. Multiply by 4/3. Remember, this is over 1, so we can just cross simplify. So you see that a is equal to 4. So our f of x is equal to 4 times 3/4 to the power of x. Okay, not too bad. A little challenging there. I thought that was kind of fun to do. All right, so guess what you get to do? You get to prove it. All right, and once you do this and you do your turn, remember to pause the video for this and then continue on, and there's the homework. Do 1 through 21 on HRW. Remember to show all your work that is to be turned in. All right, excellent. I tried to keep it under 15 minutes. I didn't get it under 10. I really wanted to. All right, bye.